welcome back to the lecture series in application of nanotechnology in agriculture. So, we are into the section where we are talking about food safety and security and preservation by using the nanomaterial based approach. So, in the previous class, if you recollect, we have talked about the whole net or the applications of nanomaterials in food industry in terms of smart food. We talked about food nanoprocessing, we talked about food nano safety against pathogen, against allergens, pesticides, and reduce the use of heavy metals and inhibit biofilm formation. And how to do this? We talked about encapsulating the food, water treatment, so in other words reducing the amount of water and keeping it an optimal water level, and humidity treatment, at what temperature you are doing without losing the quality of the food. This is very important, that you should not lose the quality of the food. And food with nano functionalities, when we talked about enhanced physical property, protection from chemical deterioration, enhanced nutritional quality, and in terms of food nano packaging, we talked about intelligent sensing of nano coated packaging, active antimicrobial packaging, bio based eco friendly edible packaging. Okay. So, these are the areas we have already talked. And now we are developing what are the steps for processing and utilization of nanomaterial in the food sector. So, we talked about the selection of the nanomaterial, recollect, we talked about the processing, toxicity analysis, product formulation, and food and safety and biosecurity. Now, what are the areas where this whole thing could be used? So, the areas include in developing nanosensors for food applications, in developing nanosensors, one critical area for food processing, in food packaging, and in food fortification and nano tracers, in food fortification and as nano tracers. Okay. Now, when we talk about food fortification, this is one area I haven't talked to you. So, that essentially means that you are supplementing a specific food with some additional functionality. Say for example, suppose you are having a vegetable, you are fortifying it with say vitamin D. In a way, you know that that particular vegetable or that particular fruit is consumed by human being. So, and you are supplying it to a location where there is deficiency of vitamin D, you can supply it with vitamin D in such a way that a person eats that fruit as well as gets the necessary amount of that particular vitamin, or similarly for vitamin A or certain minerals. Okay. So, these kind of aspects where we talk about food fortification, nanomaterials are coming up as one of the futuristic tools, which if you could convert, say for example, you have converted vitamin D into its nano formulation, you really can inject them in the food and which people will consume. Just the same way, if you think of iodized salt, which was not something, it's just you can say 4 decades old possibly. So, iodized salt is a trace amount of iodine which was added to the salt and which could take care of so many problems across the country, including goiter and all other related issues which happens in the hilly regions of the country. So, that is where, so it is not something we are doing out of the world, it is already there, we are just kind of making the spectrum bigger. So, okay, talking about in developing the nanosensors in food packaging and in food fortifications, the areas one has to be careful. There are validation of regulatory approvals of nanosensors. So, these are the technical aspects whenever we talk about the food industry one has to understand. So, the central part is the validation. This is the procedure it goes through. Validation for regulatory approval of nanosensor. Validation for regulatory approvals of nanosensors. Then user need evaluation. So, this is all done based on step 1, which is user need evaluation, because one has to first of all understand the need of the user. Without that, and of course, the acceptance of the user. Okay. So, the next is the documentation of R&D work, research and development which has happened in that area. The third one is the testing part. Whether animal trial, human trial, and what level of usage we are talking about. Next part is the calibration. Post testing, at what quantity you wanted to inject or you wanted to introduce it in the food chain. Okay. Then next come the functionality evaluation. Okay. For the intended purpose. Say for example, one claims that this particular food is fortified with say vitamin D. So, one has to do a functionality evaluation, and then next comes the validation, and that is where comes major approval. So, this is what a food material goes through in terms of acceptability, in terms of going through the whole basic research in a lab all the way to the industry and then to the end user, because one has to realize there are two areas of nanomaterials, or actually as a matter of fact I must say all the areas of nanomaterials has to go through these approval agencies because they can be incorporated into our day-to-day usage. Okay. Now, we will talk about some of the examples where nanomaterial has been used for packaging. Okay. So, let us move on. Nanomaterials for application in food packaging. Nanomaterials for application in food packaging. So, one of the major ones which are being used is, so let us make a table so that you can identify the function of each one of them, the type of nanomaterial, next is the matrix in which it is being used, third one is the applications. Okay. So, first one is silver, Ag. So, the matrix where it is being used are asparagus, asparagus, orange juice, these are some of the examples used in poultry. Fresh cut melon, you must have all seen the silver foils, which is nothing but these kind of packaging. Okay, beef meat exudates, beef exudates, orange juice. Okay, we have already talked about orange juice. Okay, now the applications are retards the growth of, now this is critical, retards the growth of aerobic psychotrophics, okay. Next, retards the growth of yeast, molds, and antimicrobial effect, antimicrobial effects against E. coli, E. coli and Staphylococcus aureus, S. aureus. So, talking about silver, you all must have seen at some point or other, in which part of India you are, it does not matter, wherever there is packaging of sweet, which is the common stuff in India, you will see people have been using silver foils for a prolonged period of time. North India, this is fairly common. In South also it is fairly common. West also it is common. East also it is common. Who taught them to use silver foil? I always wondered. And if you go to the marriages, you will see these laddus coming with a little bit of a shining silver. Who taught them this? These are traditional knowledges which has traveled from generations to generations, and today, if you ask me, we are rediscovering that wealth of what we have learned from our ancestors in a new format, nanotechnology. So, it is not that nanotechnology is something all of a sudden we are like, oh wow, we are so smart today. It was there, and it will be there, and it is there. So, many times whenever I had discussions about nanotoxicity and all these things, kind of wondered that, whether you take up gripe water, whether we talk about biochar meat, roasted and barbecues and everything, it is fair and square clear that we have been eating nanomaterials since time immemorial. Of course, there are some which are exceptionally toxic, but those are, we have never been using them. But in food products, we have been using nanomaterials for a prolonged period of time. And here is an example, classic example, silver nanomaterial. We have been using silver, but yet whenever it comes to, oh, this is toxic, we have been using it, right? So, the next one we will talk about is zinc. Zinc oxide, ZNO. So, ZNO as a matrix, we are talking about orange juice, liquid, egg albumin. Okay. Liquid, egg albumin, which is the major protein of the egg, and it effectively reduces Lactobacillus plantarum, reduces Lactobacillus plantarum and Salmonella yeast mold count without changing. So it reduces Salmonella yeast mold count without bringing down the quality parameters of the food, without bringing down the quality parameters of the food. So, zinc oxide. Zinc oxide has multiple applications. Zinc oxide is being used for water purification. Will be coming later about this. Just like titanium oxide, photocatalytically it can split, or you can take care of much of the purification of water. But zinc oxide simultaneously can bring down the Salmonella yeast or mold infestation, Lactobacillus plantarum, and without destroying the quality of the food. So this is one of the second contender in the food packaging industry. Okay. The same line, if we talk about the third one, is titanium oxide and silver oxide. Okay. TiO2, titanium oxide and silver oxide. So titanium oxide is used in Chinese jujube and strawberry as a matrix. And strawberry, where silver oxide is used in apple slice, and titanium oxide reduces browning, slow down ripening. So it reduces browning, slow down ripening. So you can use this as an effective packaging material to transport fruits, reduces senescence and the decay. Whereas in case of silver oxide, it retards microbial spoilage. So what I wanted to highlight here is trace amount of titanium oxide or silver oxide could help in ensuring that you can transport these materials at a distance. But then one has to be careful that how to wash these products. Correct instructions has to be there, and it has to be followed before the consumer uses it. Yet there are materials which are pretty benign to the body, they do not affect the body, and those could be used without any issues. Okay. So we will close in here and we'll prolong this journey subsequent week, and we'll talk about the water purification by photocatalytic methods and other techniques. Thank you.